In question 14, we're given a circle, and within that circle we have a quadrilateral. And whenever you have a circle within a quadrilateral, it's called a cyclic quadrilateral, because cyclic coming from circular and a quadrilateral within that. So for part A then, so we're told first a number of things about this, about the diagram, and then for part A we're asked to find the size of angle A, B, C, so essentially this angle there. And the size of that angle is in fact going to be 180 minus this 68 here, 68 degrees there. And I'll explain why in the next question, because it asks you to explain, but that essentially gives us an answer of 112. Now it asks in the next part to give a reason for your answer, and the reason is, as I mentioned earlier, it's to do with cyclic quadrilaterals, and the rule that we have about cyclic quadrilaterals. Now if you think about it, it's a bit hard to imagine here because you've got so many lines going through it, but this is in fact just a quadrilateral. Look, there's one side there, one there, one there, and one there. The fact there's stuff going on inside is irrelevant for now, but essentially you've got a quadrilateral, funny shape there, but it's got four sides, so it's a quadrilateral within a circle. And something that we know that we have as a rule about cyclic quadrilaterals is that the opposite angles add up to 180. So that plus that is 180, and that plus that is 180. So that is why, to work out angle ABC, we did 180 minus 68. So again, when it asks to give a reason, it's because opposite angles in cyclic quad equal, or I should say add up to, really, shouldn't I? Add up to 180. In part B, part 1 then, we're asked to find the size of angle AOC. So that is AOC, so this angle here. And the answer to that is in fact 136. And it's actually 68 times 2, and that will give us the 136. Again, part 2 asks us to give us a reason, and the reason again is this. And this is a bit harder to explain rather than just say cyclic, quadrilaterals, but essentially when you have a situation like this where you've got one single point on the circle and it's touching two external parts of the circle, and then both those parts are then joining at the center of the circle, and it has to be the center. So if you imagine you've got one part here, from there you go to two other parts of the circle, and then those parts both simultaneously come back in towards the circle. In that situation, this angle here is always double this angle here. So it's a bit hard to actually give an explanation for, but essentially what you're saying is that the angle, and that by that I mean angle, they're not L, so let me just write that as angle. It would be a bit confusing, won't it? So angle at middle is times 2 angle at circumference, and I think in one line that's about the best explanation that we can give with just one line of writing. In part C then, we're asked to find the size of angle CAE. So that is angle CAE. So essentially we're asked to work out this angle here. And the way that we do that first is to recognize that this angle here is 90 degrees. And we're trying to work out this bit here. So if we could work out this angle in here, 90 minus that would give us the one we're trying to work out. And we can actually work that out because we know that this is 136, we worked it out earlier. So we know this is 136. Additional to that, we know also that this is an isosceles triangle. The reason we know that is because that's the centre of the circle, that's a radius, that's a radius. These two lengths are the same, which means that this angle has to be the same as that. So actually what that therefore means is, and since this is a triangle, we know that the angles have to add up to 180. So what we now know is that 180 minus 136 gives us 44. And that 44 has to be equally split between these two angles here. Between that and that. Because it's isosceles, we know they'll be the same. So that means when you divide that by 2, you get 22. Now if that angle here, if this is 22, this angle here will be 90, all of that is 90, minus the 22. So therefore, 90 minus 22 will give us our angle CAE, which is 68 degrees.